On example 3, we're going to have to think a little bit harder about what our LCD is going to be. And you want to make sure you get the lowest possible denominator. So remember that in order to do it, if you can factor, you want to factor your denominators. So factor out the 3. So now when I'm looking to compare it to get the LCD, I see I need to have a 3 in it. So I'm going to put a 3 here. And I'm going to need to have that C plus 4 factor in it as well. All right, so now I'm going to multiply this times this. My 3's are going to cancel, so this is going to cancel out. And my C plus 4 is also going to cancel out. So I'm not left with anything to multiply times the 4. So 1 times 4 is 4. I'm going to change colors here. Plus, now when I go to, I also have to, even though 1 is not a fraction, it's still a term. And when I distribute, I have to distribute to it as well. So it's going to be the entire 3 times C plus 4 times 1. So I'm going to go ahead and as I multiply it, it's going to multiply out to be 3C plus 12. So 3C plus 12 times 1, and I'm going to write that right here. And then is equal to, and then I'm going to multiply it times the last fraction. This time the C plus 4's cancel, and I'm left with a 3 to multiply times the 2C, and that's going to give me 6C. All right, so then I'm ready to solve it. There are no squares, so I want to isolate my C, so I'm going to subtract 3C, and that's going to give me 3C over here, and then 4 plus 12 is 16. And then I'm going to divide by 3, and I'm going to get 16/3 is equal to C. Example B, again, I need to factor this one. So this will factor into x minus 1, x plus 1. So my common factor has got to have an x minus 1 in it. And then when I come over here, I need to have the combination of x minus 1 and x plus 1 in it. So there is both of those up there as well. All right, so now I'm ready to multiply times each of my terms. So x minus 1, x plus 1 times this, cancel that out, and I'm going to be left with x plus 1 right here. And so I'm going to distribute it, and I'm going to get 3x plus 3. I go to multiply it times my second term, which is just the 1. So I'm going to take the whole thing and get multiply it times 1. And remember that that multiplies out to be x squared minus 1. So this is x squared minus 1 times 1. So plus x squared minus 1 equals, and then when I go to multiply, it's going to cancel out both of these when I multiply times that last fraction. So everything cancels, and I just have a 12. All right, this time I have an x squared, so I want everything on the same side. Let's see, we got a plus 3x. Then I have 3 minus 1, that's going to be a plus 2 equals 12. So I'm going to subtract my 12, x squared plus 3x, subtract 10 is equal to 0. AC method, so that's x plus 5, x minus 2 is equal to 0. And then set each factor equal to 0. So x is negative 5, x minus 2 is 0, so x is equal to 2. All right, so next we're going to be talking about extraneous solutions. But before we go there, let's talk about what it means to be a solution. Now, I'm just going to show it with a 2 because that's fairly easy to do. If 2 is a solution, it means that when I plug it back in to the original equation, it's going to make it true. So if I put a 2 here, I get 2 minus 1 is 1. That's going to be 3 plus 1, so this side is 4. If I put a 2 in here, I get 4 minus 1 is 3, and 12 divided by 3 is 4. 4 is equal to 4. So that's what's meant by a solution. When I plug it back in, the left side equals to the right side. All right, so we're going to start thinking about extraneous solutions. So remember, we've had those before. They are solutions that when we arrive at them, we're doing all the correct steps, we get an answer, but when we actually try the answer out, it doesn't work. We got it when we were doing radical equations. All right, so when a denominator equals to 0, so say I plugged a 5 in right here, down here to this a, if 5 was my solution, I'd have 5 minus 5 is 0, and 20. So 20 divided by 0 is undefined. So if you get an undefined when you plug it in, it is going to be an extraneous solution. It does not check. So the answer is undefined because it's impossible to divide by 0. So exclude any answers that make a denominator equal to 0. These solutions are called extraneous. All right, so let's take a look at example 4. Easy one. Denominator is just a minus 5. So when I multiply it times the first one, knocks out that a minus 5. And, so those cancel. And I'm left with 4a plus. When I multiply it times 3, nothing cancels, right? So I'm going to end up with 3 times a minus 5. So that's going to give me 3a minus 15. Make sure you distribute. Is equal to, and when I multiply it times that last one, the a minus 5s cancel each other, and I have 3a plus 5. So this is going to be, that's going to be 7a minus 15 is 3a plus 5. Subtract my 3a, I get 4a. Add my 15, and I get 20. Oh, there it is. So a is equal to 5. When I put my 5 in to check it here, I get 20 over 5 minus 5 is 0. So 20 divided by 0 is undefined. This gets thrown out. It's extraneous. And our final answer, since there's no other choices, is just going to be no solution. All right, so pick up on the next video.